Hello there, I am Seth, and welcome to the channel. I took this rough sketch of an astronaut and generated this image. You can also take these two AI images, for example, and using multiple ControlNet models, combine elements to get a completely new image. Also, imagine how complicated it would be to color this black and white photo. Well, you can do all this with ControlNet in ComfyUI. And yeah, it is kinda complicated, but I will simplify it and show you my own graphs and workflow. In this tutorial, I will focus on 4 Control LoRA models for ComfyUI, officially released by Stability AI. These are not LoRA in the actual sense. The models are efficiently fine-tuned and are way smaller in size. These models require some unique nodes in Comfy, and their settings also have a learning curve. But they are quite powerful and have a more comprehensive range of settings than Automatic 1111. If you want to learn the basics of Comfy, then I have made an extensive 101 tutorial that explains each and every node and the connecting noodles in detail. I will leave the link to that video in the description. This tutorial is a bit advanced, and I will try my best to explain and simplify the graphs and the workflow I use in Comfy. The JSON files for the same, including the images generated, will be available in the members-only post on YouTube. So, to start off, you need the ComfyUI Manager. I did explain the installation in the previous video, but I will explain again. Go to this webpage. Click on Code, and copy this URL. Then open up your Comfy install folder and go to Custom Nodes. Over here, right-click and open in Terminal. Type in git clone and paste the link you just copied. This will clone the GitHub repository of the Comfy Manager in this folder. Open up Comfy and make sure that it's updated. Also, ensure that your custom nodes are up to date before proceeding. You can do that by clicking on Update All. In Custom Nodes, search for ControlNet. For this tutorial, you need to install the auxiliary preprocessors for ControlNet. After it installs, close Comfy via the browser in Command Prompt. You should first download the Control LoRA models before starting up Comfy again. For the models, go to this Hugging Face page. Here, you can see 2 Control LoRA's ranks. The 128 ones are smaller and less precise. Download those if you are very low on resources. Both these models are way more optimized than the default models, which are around 4 GB each. For the tutorial, I would be using the rank 256 models. The ReColor model requires 2 extra custom nodes, which I will get to later in the tutorial. Download all 4 models, as I will cover the settings and the graph workflow for all of them. The models have to be downloaded in this specific folder. Take note of that. I have created subfolders for better organization. So, I am putting all 4 models in the Control LoRA subfolder, but you can just download them at this location. After installing the Comfy Auxiliary Custom Node, I get this registered path in the command prompt. Just ignore this, as it is not a problem. This goes away when you disable the custom node. This started appearing only after updating everything to the latest version. This specific warning has to do with the DW Pose preprocessor model. I am not covering the DW Pose at all in this tutorial, but I will explain to you what the issue is and how to fix it. The DW Pose is more advanced than the Open Pose ControlNet in Comfy. To make it work, you need to install the on next runtime either for the CPU or GPU. Go to the Python embedded folder in Comfy. Right-click and open in Terminal. Type the following to install on next for the CPU. If it is already installed for the CPU and you want to install it for the GPU instead, you can uninstall it by typing the following. Then, type this to install for the GPU. The problem is that it does not work on the GPU if you have CUDA 12 and above, which is required for Torch 2. If you go to their website, the latest version, 1.16, supports CUDA 11.8 only. So, if you want Torch 2, you have no option but to run the DW pose on the CPU. Unless they release an update, there is no way to run it on the GPU. You can verify that it is installed on the CPU correctly. Inside the Custom Nodes folder, there is a folder called ControlNet Aux. Open the requirements file in Notepad and add this text on the last line, then save and close. Now run the install.bat file, which should show requirement already satisfied. You are good to go and can run Comfy, ignoring that warning on start. Okay, I have divided the workflow into 3 parts. All of them are unique and have different nodes. In the first workflow, I will start from scratch, and for the second and third workflows, I will adjust nodes as needed. Let's start by adding a load image node. The image output should be connected to a ControlNet preprocessor node. For the first workflow, I would showcase the Midas Depth Map ControlNet model. Midas has a depth and a normal map. Both of them are different. The depth map encodes the distance of the elements in the image from the camera's viewpoint. Black means very far off, and white means very close. The normal map, on the other hand, is used to measure light direction on a surface. In other words, it shows how the light bounces off and interacts within the image. Using the light map in conjunction with the depth map can add more realistic lighting and surface details to the image. For this workflow, I will only use the depth map for now. Whenever using SDXL, it is best to use the default resolution of 1024. Now, I will add a checkpoint node. I am using the RealVis XL checkpoint. This model can be downloaded from Hugging Face or Civet AI and is still in training. It's about 30% completed, and so far, I found it very good for photorealism. Now we'll add the positive and negative prompt nodes. To duplicate, hold down the Alt key while selecting and dragging the node. Connect the model output to the K-sampler, and let's select the advanced sampler here. In case you load a checkpoint that requires a different VAE, you can do the same by adding a node from Loaders. Load VAE. You can select the model from the list and connect the output to the VAE decoder directly. For this checkpoint, I don't need a separate VAE. For ControlNet, add a Load ControlNet model node. Remember I said earlier that you could organize the ControlNet models into folders? They show up in Comfy. It becomes really easy to select when you have a very long list. One thing you should note is that the ControlNet model should always match the ControlNet preprocessor. If these two nodes do not match, you get weird and distorted results. The ControlNet output should be connected to the ControlNet apply node, and I prefer the advanced one here as well. The strength value defines the ControlNet weight that you want in your image. The start value percentage is when you want the ControlNet model to kick in during the generation process. For example, a value of 0.5 would mean it starts using the ControlNet models at 50% of the steps defined in the K-sampler. In the same way, you can also define the end steps. This comes in very handy when using multiple ControlNet models. You can define one model to end at a specific step and the other to take over from that step. The positive and negative outputs connect to the ControlNet inputs. You then connect the ControlNet, positive and negative, to the K-sample inputs. The image output on the preprocessor will connect to the apply ControlNet input. There are multiple ways you can connect the latent image input on the K-sampler. One way is to load an empty latent image and feed it to the K-sampler. However, for ControlNet, I do not recommend that. This is because the empty latent image is not encoded with any data. What we actually want to do is push the data from the loaded image to an encoder and then pass it on to the sampler. In order to do that correctly, search for a node called Image Scale to Total Pixels and connect it with the load image output. Leave the setting as it is and connect this node to a VAE encode. Now, connect the latent output from this node to the latent image input in the sampler. Connect the VAE output on the checkpoint with the input. Let me explain what I did here. The load image has pixel data. The technical term for it is called pixel space. The VAE is called a variational autoencoder. It is basically responsible for transitioning the data in the images between the pixel and latent space. So basically, the VAE encode node takes the data in the pixel space and transforms it into a compressed encoded form, capturing the essential features of the image. The output of this process is known as a latent image. When we connect the latent output from the sampler to a VAE decode node, it does the exact reverse. It takes data from this latent space, reconstructs it, and transforms it into pixel space. The process output is an image, which is the final generated image we see. To finish the graph, connect the checkpoint VAE output to the input in the decode node. The graph is now complete. Let's add positive-negative prompts, change the sampler settings, and generate the image. Nice! I will show you how to upscale the image as well. I use the Ultimate SD upscale from Coyote. You can find it in custom nodes. If you don't have it, after installation, save your workflow and restart Comfy from the command prompt. First, delete the connections to the preview and save image nodes. Drag out the connection from the decode node image output and search for Ultimate SD upscale. I have made a full tutorial on how to use this node in Comfy. The tutorial covers text-to-image and image-to-image upscale workflows. I will leave the tutorial link in the description below. Here, I will take the final generation and do an image-to-image upscale without adding any extra details. Connect the relevant inputs from the checkpoint and the prompts. The Ultra Sharp and the Full Hardy Upscaler both work well here. Connect both the preview and save image nodes to the upscaler node and generate the image. Now we have a 2x upscaled image. Here are the results for comparison. Focus on the black circle on all three images, and you can see how the building structure is maintained via the pass-through method. Now, if you focus on the white circle, you can see the image via the pass-through method maintains the color tone and temperature, whereas the empty latent image is way brighter. Also, notice the hair lighting within the black circle. The pass-through is more close to the original than the empty latent. This is why you should use a pass-through for ControlNet instead of an empty latent unless you want a wholly restructured image. These results will vary to a greater or milder extent depending on the checkpoint, the prompt, and the workflow altogether. Let's try multi-ControlNet using Canny Edge as the second model. I will rearrange and duplicate some nodes. I want a pirate-style dress and hat. Canny Edge ControlNet is perfect for outlining these elements. Here, the first ControlNet positive and negative conditions will pass through the second ControlNet node. The second ControlNet node will connect to the sampler node. You can connect as many ControlNet nodes as you want. The Canny edges come out very sharp. To balance out the Canny effect, I will reduce the strength to 0.1. Also, I want the second ControlNet to start applying from 50% of the steps. I am not changing the first ControlNet apply node, as I only want certain elements from Canny without drastically changing the image. Adding pirate cosplay to the prompt. To explain, the first image is still being passed through from the encode node to the sampler. The second image is purely Canny. If you want, you can connect the second image to the encode node. What you can also do is pass both the images through two samplers. That will complicate things further. It has blended the elements exceptionally well. For ReColor, you need to install some extra custom nodes. The Stability ComfyUI nodes will give you the Color Blend node. For the Color Correct node, you will need ComfyUI post-processing nodes. I would delete some nodes, as you don't need them for this workflow. There are 3 new nodes needed. I will add 2 for now, which are Color Correct and Color Blend. I will disconnect some nodes as they need to be reconnected differently. Connect the Load Image and Color Correct nodes. The Color Correct image will go through the pass-through method. So, it should be connected to Image Scale to Total Pixels. What will happen here is the black and white image can be color corrected in terms of temperature and tone. After adjusting the settings, the color-corrected image will then pass onto the sampler via the encode. This node will have 3 connections. One will go to the black and white layer input in color blend. Second is the pass-through, which will connect to the pixels input in VAE encode. Lastly, you would want to see the preview of the color-corrected image. So, connect it to the preview node. Connect the VAE decode node with the color layer input in color blend. The color blend node blends the colors and generates the final image. Connect the node to the Ultimate SD upscale image input for upscaling. For recolor, only use the base SD XL checkpoint from Hugging Face. I will change the value back to 2 later on. I am disconnecting the node to show you what exactly you can do with the color correct settings. I will change each setting and show you the output. This is very important as the color accuracy depends on what you do here. A positive temperature will make the color warmer, and a negative temperature will give it cooler tones. If you are seeing too much red in the final image, make it cooler. The hue will not show in the preview but is basically a tint setting and applies to the final image. I found it best to leave it at 0. A positive value will increase and a negative value will decrease the brightness. Contrast is where the images might pop. I rarely have used the minus value. If you want the overall image to be washed out, use a negative contrast value. Saturation is also applied to the final image. If the colors have too much bleed, change the saturation to a negative value. Higher the gamma, darker the overall image. This setting is sensitive. Try 0.8 to 1.2 values, then go higher or lower. I forgot to mention earlier, you have to connect this node to the Apply ControlNet input as well. This is the default negative prompt from Stability AI. Keep the positive prompt short and to the point. For this image, I am using minimalistic, geometric, vector art, colorful. The coloring style will change with the seed. Sometimes, you will get better and more accurate colors. What I do is choose a random seed and keep it fixed. Then, play around with the color correct settings. If you cannot get what you want, change the seed. It is recommended that you follow the default settings. Steps at 30. The sampler should be Euler Ancestral, and the scheduler should be normal. CFG should also be at 7. You can play around, but I highly recommend you start with these values and then mess around. With a proper positive and negative prompt, it does an excellent job. If I did not include colorful in the prompt, this comes out as a monochrome color. Another thing I find very useful is to have a batch process. With that, I can generate multiple images with different color options. Disconnect the color blend node from the sampler input. Search for repeat latent batch and add that node. Connect the output to the sampler input. Now connect the VAE encode latent output to the sample's input. Let's generate a batch of 8 images. With batch, you get a wide range of colors. This is not only useful for different color options, but when you try to color a real photo, you need batch processing. Many times, a couple of images from the batch will be accurate. It depends on the seed. Let me show you another example. For any photo, use this prompt. Color photograph, detailed, DSLR, natural skin, highly detailed. In between, add a few descriptive words about the image. For example, I have added female, floral dress and floral pattern wall in the prompt. The prompt will have an effect on such images. I cannot advise you to be less or more descriptive, as it depends on the settings and the image itself. So try it out. The original image was quite dull, so I enhanced it. You can see how the image has a cool bluish tone. The default setting was producing too much red. Here's a comparison. The fourth image is the best. That is what I used for the opening scene. Let's move on to the final workflow. For Sketch, I have to delete irrelevant nodes. It is recommended that you use a latent empty image for the sampler. The Sketch ControlNet model can be used to color the drawing input, mostly white on black images. It works on hand drawings too. Add a Scribble preprocessor node. I will use the Sci Animated XL checkpoint here. For this ControlNet, start with a lower than default strength. 0.7 should be fine. You can then increase or decrease as per requirement. I want to stylize the final image a bit. For this, I am reducing the end percentage to 0.4. Beautiful! I hope this tutorial was helpful and you got to learn something new in Comfy. Until next time.